So machine learning in the warehouse with Python and Snowpark. Really excited to give this talk. As mentioned, I work for DeepNote. We build this amazing data science notebook platform. You'll get to see it in action a little bit later. I actually am a solutions engineer as of recently, so I get to use all of my data science skills and I get to work with our customers, help them define solutions that work for their workflows. It's a very, very exciting role. My background and my sort of first love is really in the field of neuroscience and statistical software development. And so I've been very interested in taking statistics that might be sort of intimidating for some folks and sort of bringing it in and communicating it in a way that the rest of us can actually make use of. So that's a bit about me. I want to tell you a little bit about DeepNote and Snowpark and how they can work together. As Snowpark does a lot of different things. And so I will try to break those things down for you. And so you can see how you might use it for your own machine learning work, data science work. I wanted to give you just a little bit of a pathway of the sort of DAG or the sort of process that I'm going to be describing in this notebook that I'll show you a little bit later on. But if you look at this, this schematic here, this visualization, I want to show you how we can take data from this sort of initial transformation or raw form, which of course is, all data starts in this sort of raw form, and then we take it through a series of transformations, making it more and more readable for humans as we move from the left to the right. Eventually you get into this stage where you're exploring your data, you're visualizing it, you're trying to figure it out, and you're kind of getting into it as a data scientist. And then once you're sort of done with this EDA or exploratory data analysis, you start prototyping your models. You start taking a small sample of data, seeing, learning the correlations in your data and prototyping it. And then eventually you want to train your model fully and deploy it. So you really start with this raw data set and you move it through a series of stages until it's something that you can use for machine learning. So this is a very generalizable workflow. So things that we're going to learn with respect to Snowpark and DeepNote to some extent. I'm going to show you how we can write SQL without actually writing SQL. This is going to be useful for people who prefer Python. We're going to learn how we can do EDA, otherwise known as exploratory data analysis, without actually writing a lot of code. And we're going to look how we can actually do machine learning, but minimize the amount of data that we have to move back and forth from, let's say, our client to our server or our local laptop to some remote cluster or something. So we're going to see if we can minimize some of those rough edges without without moving our data around or changing our tools. And I'm going to actually give you a demo of this as well, so you can see it in action. And I will be providing all of the resources that I show with you so you can play around with it as well. So on the way to the demo, I wanted to just give you, even right now, just an overview of what I mean by all of these things that I'm sort of summarizing already. What do I mean by writing SQL without writing SQL? Well, for those of you who are familiar with PySpark or DuckDB or Pandas, you know that working with a DataFrame API or a DataFrame abstraction in Python is quite useful, and you can do SQL-like things with it. Well, with Snowpark, it's no different. With Snowpark, you can very easily do SQL types of things, but just using Python methods that on objects that Snowpark makes available to you. In this particular example, I have two data sets, df demo, df serve. It's just a demographics table and a services table from a telecommunications data set. And then I'm joining the two of those together on customer ID, that's the third line. And then I'm actually writing that new joined table as a new table in my warehouse. So you can see this is a very SQL-like thing to do, but it's quite nice working with this in Python. Now, Snowpark, as I mentioned, does a lot of things. One of the things that it allows you to do, of course, is aggregates, group bys, transformations, all sort of being controlled from, let's say, a Python interface like a notebook, but it's actually running in the warehouse. And so this is really helpful for fast EDA, of course. And here you can see a really simple example, something that you might be familiar with, if you're familiar with pandas or PySpark, where I'm grouping by 2 dimensions in my data and I'm doing some aggregation and some sorting. And so without really having to do much, I can already start to make sense of my data. Now, again, Snowpark does a lot of things. Not only does it do all of this sort of transformation with this data frame abstraction, but it can also help you to train and deploy your machine learning models actually in the warehouse. And this is quite interesting because it's often a problem when you're in a notebook, you have the limitations of your laptop, you want to train a model, and then eventually you want people to be able to interact with that model. Maybe they need to call a dot predict method, they want to return some predictions, and it's like, where do you put that model now? Well, Snowpark gives you a way of actually storing that model in the warehouse itself, and then any kind of external application can actually read from that model or call methods on that model object. So it's nice. It's a really cool. It makes for a really cool, smooth workflow for many machine learning jobs. So here, what I'm showing you here is just a little code snippet where I'm taking a function that I have in my local notebook environment, and I'm saying, hey, take this function, take everything that it does, and just put it in the warehouse and let me run it there. And so the very last line is actually me calling a training function that I defined in my notebook, but actually letting it run sort of remotely in the Snowflake warehouse. So this is pretty interesting, and that's the only sort of little bit that you have to add is this registration. So I'll show you how all of this works in practice as well. Okay, let me just quickly move over to a notebook, and I hope you can see this. So I'm going to walk you through a bit of what Snowpark actually looks like in the notebook. I won't spend too much time on all of the nitty-gritty, but basically this is deep note that you're looking at here. I can give you a quick lay of the land. We have like workspace. Workspace is here on the left, and projects. It's slightly different than how Jupyter works, where we have workspaces, and workspaces contain projects, and projects contain notebooks. I also happen to have an integration with a Snowflake warehouse here in my notebook, and this makes it so I can write SQL against my warehouse natively in the notebook. So it's Python plus SQL. So here I am in the notebook. I'm authenticating into my Snowpark session. So I won't share too much of that with you. In fact, I think I'll just skip down to where the fun machine learning bits happen and sort of describe a few things that happened along the way. Okay, so I'm going to share this notebook with you as well, so that you can see all of the specific details. But just remember that this notebook shows you how to take raw data, and I actually bundle the data, the Parquet file for this raw data right in the notebook itself. So when I share the resources later, you can duplicate this into your own workspace. And as long as you have a Snowflake account, which is free, and a DeepNote account, which is free, you'll be able to actually run this entire machine learning pipeline for yourself and see how it all works. But yeah, this notebook will actually execute and put into practice this entire pipeline that I've shown here, where we have raw data through a series of transformation stages all the way to something we can use for machine learning. And so I'm going to skip through all of the transformations that I'm doing, but you can see it's just following exactly the visualization that I showed. So here's all the associated code. Eventually, though, you get down here and you're like, okay, hey, my data is all transformed. I want to start looking at it now. I want to start visualizing it, and eventually I want to work towards training it and deploying it. There's a few things to mention here behind this UI. As I mentioned before, Snowpark gives you this data frame abstraction, and so you can call these methods. This is actually something that I showed in my Google Slides earlier, and then you get this. You can convert the result set to pandas. Whenever you call this toPandas method, which is a Snowpark method, then it actually brings the data into memory in the notebooks environment. Okay. And so here you can see I'm just looking at this telecommunications data set. I'm actually concerned with the customers who are churning. And in this case, I can look at whether they churned or not, how many churned based on the kind of contract they had. So pretty straightforward stuff, but I just wanted to show you how that looks in the notebook. You can even call the .explain method if you like on any data frame. And what it will do is actually show you the underlying SQL, which could be quite helpful, because after all, these things are really just like wrapping around SQL. Part of what makes Deep Note so nice and such a good fit for Snowpark, as you can see, is that we have a lot of sort of built-in EDA helpers and superpowers that help you sort of understand your data without having to write a lot of code. And so it's a good fit. You can actually see here that I have taken a sample from my warehouse from this table telco dataset or telecommunications dataset. I've brought it into the notebook's memory with toPandas, and I've just displayed the first 50 rows in Deep Note. And you can see right away, without doing any work, you get like ratios of your data. You get histograms and different things. You can sort and filter and even paginate and download this data. So this is pretty nice. This is a really, I think if you're working with data, you sort of want to be able to understand it as quickly as possible. So we try to build these things in. We also have these various different kinds of blocks. And so here I have a chart block. You can think of it like a special kind of cell. Again, we can pass data frames into these chart blocks and explore them very, very quickly without having to write a lot of code. This is actually great for things like colored scatter charts or grouped histograms like this, which are kind of annoying to make if you have to write code for them all the time. So here it's very simple. You just pass in a data frame to the chart block, and then you point these fields to columns in your data frame. And we use the underlying Vega Light visualization library to render these charts. So this is quite nice. Okay. Again, I mentioned earlier that we're also connected to our Snowflake instance. And so here you can see that I'm actually writing just SQL. This is an SQL block. And again, we can start exploring our data. You can even parameterize queries in different ways by having these sort of widgets and blocks and to sort of add like a UI element to your queries or your Python or your Python blocks as well. So this is quite nice when you start to think about, hey, I've got a great tool for transformation all in Python thanks to Snowpark. And then I can, with the Snowpark data frame API and some of these built-in EDA superpowers, I can really start to understand my data without having to duplicate a lot of code or have to think too much. So I want to get to the machine learning part and just give you the sense of how this all works. So suppose you're a data scientist and you're exploring, you're sort of done with this like initial exploration. You want to start prototyping a model. You end up with, in this case, I just have a model that's returning some accuracy scores, and it's also saving the model object itself, so I can actually use it. And it's, of course, it's training. It's actually fitting the model, and it's doing all kinds of standard sklearn types of things. And so you have this function, and you're like, okay, this is cool. This works in my laptop. I'm very happy with this. Fine. But it's working, again, this is working in the client or locally. And so there's no problem. I can call this and run it locally, and I will get the output back that I expect. Fair enough. What's really cool about Snowpark, though, is that you're like, okay, I've got this function, but is there a way I can just move this to run, let's say, push down or run it down in the warehouse itself? And yes, as I mentioned before, this is one of the value propositions for Snowpark. You can simply take the function that you've defined in your local environment or your client, however you want to think about that. And you can say, hey, take that function, give it these libraries, this is sort of going to help define the environment, and store everything in some storage location in the Snowflake warehouse, and then that's basically it. That's you registering a local function, but you're registering it sort of remotely. Once you do that, anything that function did, including like saving the model object itself, all of those things get stored on the Snowflake side in the stages that you define. I just think of a stage as like a sort of a place to store artifacts or a place to store assets that you want to access later. And any of the output that function produces, well, you can interact with all of that just by calling that function that you've registered, along with any inputs that function takes. And so I want to contrast this line, which calls this function train churn prediction model and passes this data set in. This will actually run in the Snowflake warehouse itself. And of course, it returns the output that you'd expect. And a slight contrast with this, which runs exactly the same function with exactly the same data set, but runs it in your local environment. So this is part of what Snowpark is bringing to the table. Hey, it's like prototype your models in your notebook, and then when you want, you can actually run that right next to the data in the Snowflake warehouse. Of course, you might be thinking, well, you save that object in a stage in the Snowflake warehouse. How do you actually do anything with that model, with that object? Because typically when you train a model, you want to actually pass new values into that model's predict method and return back predictions. Like, this is a classification model after all. So you can do that by using these so-called Snowpark UDFs, or user-defined functions. And basically, without getting into too many of the details, the user-defined function will just allow you to actually call the predict method on the object that's living in the warehouse. And the way these functions work is kind of interesting, actually. If you look at this select statement, this is basically, you can think of it like SQL if it makes it a bit easier. But it's saying, hey, for every row I return from this select statement, can you actually take those values and pass them into the model's predict method? And this is like kind of interesting because it feels like you're just calling an SQL method, but that SQL method or that SQL code is also kind of interacting with Python, on the back end, and calling this predict method. And so for every single row in this result set, I'm actually getting a new column called predicted churn. And this is actually returning the results of that predict method. So this is a really, really interesting way of building machine learning pipelines, where you're storing this object. This is a Python object. It's sitting in the cluster, or it's sitting in the Snowflake warehouse, which is like an Anaconda environment. And you're saying, hey, I can actually call methods on that object and have them show up alongside any row in my result set. So there's, the sky's the limit. You can be quite creative with this. You can imagine something like this driving, let's say, like a dashboard or something, right? If you have a Streamlit app and you want to serve up, like, hey, these are the customers most likely to churn. You want to serve that up to your stakeholders. That Streamlit app can essentially be running this Python code, which is connected to your Snowflake warehouse and calling that predict method via these UDF functions, and then visualizing those in some way in your dashboard. So this is really, really cool. You can, of course, very easily chain these methods together as well, and actually write those predictions to a new table, let's say. And this is also a really nice way of taking that data and not making it ephemeral, but actually saving it right next to your data. So this is also a really really good method, a really good technique. Okay, so I want to just very quickly go back to my presentation and give you a bit of a summary of what we've learned. Okay, so Snowpark does a lot of things. It's great for transforming your data in your warehouse. Of course, you can do anything that you do with SQL. You can pretty much do that with Snowpark. But it also adds these like machine learning use cases on top of that, allowing you to take a function that you have running locally and basically define a Conda environment, essentially, where that function and everything it needs can actually run right into the warehouse, or run right in the warehouse next to your data itself. So this is already huge because you don't have to, switch to a different language. You don't have to switch to a different tool. Your prototyping code and the code that runs in the warehouse are essentially the same. And then on top of that, any objects that are stored in the warehouse can be accessed with these UDFs, so that you can sort of drive dashboards and a front end on top of what's happening in your warehouse. It really does feel like, for some people, quite a smooth way of doing machine learning workflows, which are like notoriously hard to productionize. And then, as you saw, of course, we are using Deep Note as this control surface. Really, that's what we're doing. We're saying, hey, we need a control surface for all of this. And there's a whole bunch of superpowers that are built into that help you with exploratory data analysis, like these rich data frames you can explore without writing code, and of course, chart blocks and these UI, these widgets. So all of these things together, ideally, they make a data scientist's life much easier. If you want to, you can point your camera at this QR code, and you'll be taken to like notebook resources you can use to actually poke around and experience Snowpark and Deep Note for yourself. So that about does it for me. Thank you very, very much, and I have some time for questions.
Thanks for that, Allan. Let me go ahead and look at the job board here. Yeah, we have a few questions for you. Let's see. Would you have the link of this notebook?
I do. Where's the best place for me to share that
If you just type it in the chat, I'll make sure that it gets
you can
on
share it,
the,
right?
yeah,
Ah,
I'll
okay.
make sure.
All right. Yes, indeed. I can do that. Also, yeah, that for those who are going to be here later as well, the QR code will take you to things, but I'll share it with you.
Perfect, perfect. All right. Next question we have is performance-wise, how does Snowpark compare to other major frameworks like PySpark, Plain Pandas, etc.?
Mm. Yeah, that's a good question. My understanding is that if you had like if you wanted to pay for like a really performant cluster on like AWS EMR or something, and you wanted to PySpark at it, you could probably work on like just gigantic data sets and have everything distributed. And if you really need that, then go for it. I think, and you'd have to ask the Snowpark people or the Snowflake people how they can actually provision better machines for you if you need data at scale at that level. But like the Conda environment that I'm using right now in the notebook that I just showed you, I don't think it could compare performance-wise in terms of data storage and RAM capabilities as like if you spun up a cluster, like an EMR cluster or something. So I think you could check with the Snowflake people to see how upgrading that environment would work. But there are currently, I think, at least for my environment, some limitations. So I'm definitely not going to be training on millions of rows of data or anything in this environment. So basically, I think if you want to pay for it, you can scale it up, but I'm not sure how that works.